Hello guys, welcome back to a new session. In this session, we'll be talking about the organic chemistry. Organic chemistry is all about two chapters, chapter 9 and chapter 10. In the first chapter, chapter 9, we'll be talking about four sections. The sections here at the beginning, we'll be talking about the abundance and importance of carbon. We will introduce the allotropes of carbon, and in the second section we'll be talking about the organic compounds. The third we'll be talking about the hydrocarbons, but the saturated hydrocarbon, and the fourth we'll be talking about another group of hydrocarbon we call as the unsaturated hydrocarbons, guys. Let us talk about the importance and abundance of carbon in our daily life, guys. Carbon is one of the crucial element, an important element we'll be talking about it, and the chapter 9 and chapter 10 all based on the carbon atom. Let us talk about how the carbon important to our life, guys. First, carbon is found in nature in both elemental and in combined form, guys. We can find the carbon both as carbon element, and as including in the compounds. For example, C6H12O6, this is a compound, or CO2 is a compound, or more other combined form of carbon. So the carbon can be obtained from the compounds in combined form and in pure form as carbon itself. In terms of the abundance in Earth, it's ranks the 17th element by mass. It's the 17th element by mass in Earth's crust, guys. It's important for us. Why? Because it's the ingredient, or one of the ingredient in all living organisms and matters. Some of those compounds or things that contains carbon are the body tissue, food, and the fuel that we use for heating. All of the stuffs around us, guys, contains the carbon, including the non-living and living organisms. So the matters which are in our body, the tissues, contains the carbon. The foods, the drinks that we drink and we eat are containing carbon. The fuels that we use for heating as well, they contain carbon. In terms of bonding, guys, carbon has got 6 electrons. The 6 electron distributors, 2 of them in the inner shell. You studied this in grade 10, and 4 of them for the outer shell. Due to having 4 electrons in the valence shell, it has tendency always to form 4 covalent bonds. It has tendency to form 4 covalent bonds. So carbon always, in order to be stable, it must form 4 covalent bonds with the neighboring elements or with the carbon as well. In terms of the structure, the electron configuration, it's 1s2, 2s2, 2p2. This refers to the electron configuration that you have studied. Just know the electron configuration of carbon. It's not necessary to know the electron configuration for the other elements, guys. In terms of the type of the bonding, carbon has 3 hybridization we call. Hybridization, you may have studied in grade 10, is a process which the orbitals of carbon are overlapping each other. When the orbitals they overlap each other, there will be different shapes and different bonding types for the molecule that we call the hybridization. So it's the theory that explains the bonding and geometry of most carbon compounds. The hybridization refers to the bonding and the geometric of the carbon compounds, whether it's single, double, or triple bonds, because carbon has tendency to form single, double, and triple bonds. Guys, in ministerial exam, it's important to know the sp3, sp2, sp, which is the hybrid orbitals, the form of the hybrid orbital, and then the shape of those hybrid orbitals with the type of the bond, single, double, and triple. So sp3, you have to know it's all for single bonds, sp2 double bonds, and sp triple bond in the structure. As you can see here, we have got the 4 single bond and a tetrahedral shape, guys. Tetrahedral shape. And we have got, that's sp3. For the sp2, we have got double bonds, and the double bond almost like the planar, we call as the plane, okay? And for the sp triple bonds, we have like a linear form, that's why it produces a linear shape, and then has a triple bond. It's important to be known the type of the hybrid orbital with the type of the bond are most important for the purpose of ministerial exam, guys. Let us talk about the allotropes of carbon, guys. Carbon has got 3 allotropes. Allotrope is the same element but with having different properties and different forms, different shapes as well. We have got 3 allotropes of carbon. The first one is diamond, and then graphite, and then fullerene. The diamond, which is the most expensive and the most strong structure of the carbon, is a what? Is a colorless, in terms of color, crystalline, solid form of carbon. In terms of the color, diamond, the nature of diamond is colorless, and then it's a solid crystalline form. Another graphite is another allotrope of carbon, which is a black crystalline soft form of carbon that's fair conductor of electricity. This allotrope of carbon is recognized by having a delocalized electron we'll be talking about, and it conducts the electricity. The fullerene, which is the third form of, or the third allotrope of carbon, is a dark colored solid made up of spherical neutral carbon atom cages. We'll be talking about the fullerene as well. It has no applications, but we'll be talking about the structure and the formation of it with the examples. Let us talk in detail about the diamond. What's important about the diamond? The physical properties are important. The distance between the atoms are important. The applications are important. The first thing is that we have to know it's the hardest material that known, and it has a tetrahedral shape. Its structure is what is tetrahedral shape. In terms of density, is the most dense form of carbon. So in all the 3 allotropes of carbon, diamond, graphite, and fullerene, the diamond is the most dense form of carbon, and it's 3.5 times denser than water, guys. It's 3.5 times denser than water. In terms of the melting point, the melting point is high, almost greater than 3,500 Celsius. In terms of the formations, a carbon atom in diamond bonded covalently in network fashion. So in the diamond, carbon atom bonded 4 single bonds with the neighboring other carbons, guys. The distance between the atoms is 154 picometer, What do we mean by the distance between the atoms? Here is represented from the nucleus of one atom to the nucleus of the other atom. It's what? It's 154 picometer, which is a small distance and a short distance. Each carbon atom tetrahedral oriented to its four nearest neighbors. So it's connected to the four nearest other carbon atoms. Use it in cutting, drilling, and grinding because it's the hardest substance. It's used for cutting, drilling the oil well especially, and grinding the hard materials. In terms of conducting heat and electricity, it's one of the best material which conducts heat, but it does not conduct electricity. So it conducts heat 5 times more than the silver and copper. Guys, you know silver and copper, they are good conductors of heat, but due to having a short distance between the nucleus of the atoms of diamond, it leads to the diamond structure to transfer heat and conduct heat much than the other metals, which like silver and copper, which are good conductors of heat. So the heat is conducted by transferring of energy of vibration from one atom to another atom. From the one atom, heat is transferred to the other, to the other, to the other by the vibration of the atoms. The heat conducted or transferred in diamond very quickly because the diamond atoms are close to each other. But unlike the metals, guys, it's not a conductor of electricity. It does not conduct electricity because it does not contain the free electrons in its structure. Let us talk about the graphite, guys. Graphite. The graphite is another allotrope of carbon, which we'll be talking. The graphite, unlike the diamond, it's used for many other applications, but it's a good conductor, or we can say a fairly good conductor of electricity because of having the delocalized electron we'll be talking about. It's remarkable for the softness, feels greasy, and crumbles easily because its structure is thin. Guys, graphite is used in the lead pencil. When we touch it, it's almost soft and feels greasy, oily, and its crumble can be smashed easily because it's thin. In terms of the shape, it's a hexagonal plates. As you can see from this shape, guys, are the hexagonal plates of the hexagons. All they connected to each other with the other hexagonal plates. The distance, guys, the distance between the atoms in the same layer, it's 142 picometer. But the structure of graphite, we have layers over the layers over the layers, guys. Are all layers over the layers. The layers are connected by London dispersion force. In between the layer the only existed force is what? Is London dispersion force. And London dispersion force is weak and can be broken down easily. That's why when a lead pencil is writing, the light layers of the graphite glides on each other, and the London dispersion force can be broken down easily. But the distance between the nuclei in the adjacent layers, guys, is 335 picometer. From one carbon in this layer to the other carbon in the other layer, it's 335 picometer, which is much higher than the distance between the atoms in the same layer and between the atoms in the diamond. That's why in terms of density, this is less denser than the diamond. There is, as I told you, there is a weak London dispersion force between the plates, between the layers, and this force easily breaks and slides one another, that makes it to be used as a lubricant and graphite fiber and the lead pencil as well. It's used as the lubricants to be lubricated, and then graphite fiber and lead pencil as well. The strength and the lightweight of graphite fiber, it's somehow strong, and in terms of mass, it's not heavy, have led to its use in production of the sporting goods and the aircraft bodies, guys. Sometimes in the airplanes, the body made up, or in the cars as well, made up of the graphite fiber, guys. Within each layer, carbon atoms is bonded only to 3 other carbons. But we said carbon always must form 4 bonds in order to be stable. As you can see from the structure, guys, here the carbon atom, each carbon atom bonded to the other. For example, if we take this, bonded to the other 3 carbons. How about the third? The third is what? Is the delocalized the fourth is the delocalized electron. We will be talking in detail. This type of bond are examples of resonance hybrid bonds. Resonance hybrid bond is a bond that all of the bonding are not solid bonds. 3 of the bonds are connected covalently. One of the bond is due to of delocalized electron in the structure. Graphite fiber are stronger and stiffer than steel. It's stronger and stiffer than steel, but less dense, and the strength of bonds within a layer make graphite difficult to pull apart in direction parallel to the surface of the layers. They are strong, that's why we cannot let the layers to pull apart. The strength and the lightweight of graphite fiber, as I told you, leads to the production of sporting goods and the aircraft bodies. The delocalized electron, guys. The bonding electron of resonant bonds can be thought of as delocalized electron. What's a delocalized electron? Delocalized electron, an electron has no location. Delocalized. It's shared by more than 2 atoms. More than 2 atoms simultaneously. Electrons are shared by more than 2 atoms. The electron, the carbon, each carbon in the graphite bonded 3 covalent bonds. And the fourth is what? Is the delocalized electron, which continuously rotating and continuously moving in the structure. As continuously the electron moves, there should be a free electron. We call this electron as a free electron in the structure. And as there will be free electron in the structure, it provides a tendency and a property to the graphite to conduct electricity. That's why it's a fairly good conductor of electricity, even though it's non-metal, because the delocalized electrons move freely within each layer. The delocalized electron moves freely. It has a high melting point, 3652 Celsius, because the structure created by delocalized electrons results in a strongly bonded covalent networks, and as the covalent network strength increases, that needs more heat to boil the graphite. Let us talk about the fullerene. Unlike the other two types of or other two allotropes of the carbon, the fullerenes has no practical applications. It has got practical application, but according to our curriculum, it says it has no practical applications. Fullerenes are a part of the suit that form when the carbon-containing materials are combusting. When we combust the carbon-containing material, the remainder we call the ash or the soot is the fullerene. So the fullerene is the ash or the soot that remains after the combustion of the carbon-containing compounds. The most stable form is C60, and we call as the Buckminster fullerene. This is the secondary name of the fullerenes. And the structure has a 5 and 6 membered rings. Let me show you the structure, how it is 6 and 5 membered rings. As you can see here, we have got 1, 2, 3, 4, 5. It's 5 membered ring, and then 1, 2, 3, 4, 5, 6. It's 6 membered ring. The 6 membered ring with the 5 membered rings are forming the structure of the fullerene. They are connected to each other, 6 with 5, 6 with 5, 5 with 6, so they form a 60 carbon. It's almost like the cage shape and like a soccer ball as well. So the structure is the 5 and 6 membered rings. No usage practically found today according to our curriculum, the book. Structure of C16 also resemble to the design of soccer ball. That's why sometimes we call as what? As a buckyball. C60 covered as a buckyball, and Buckminster fullerene as well. Let us solve some ministerial exam questions, guys, in this section. Said one of the carbon isotopes is a black crystalline substance and electricity conductor. The only allotrope which conducts electricity and black crystalline is graphite. So graphite is the correct answer. Hybridization of carbon orbital in methane. Methane is CH4, which all of the bonding of the carbon is single bond. So the single bond is sp3 hybridization 4. Carbon atoms form double bond, so double bond when the hybridization is sp2. sp2b is the correct answer. Which of the following properties is not correct about diamond? Is not correct about diamond. Conduct electricity well, it's not correct. So conduct heat, incorrect. It's conduct heat, but is it not correct? High dense, high melting point. So conducting electricity well is not a property of diamond. What's the hybridization form of ethene gas? We will be talking about the alkene, and alkynes. Whenever it ends with the ane, that means we have got single bonds, guys. Single bonds. Alkene, ene, double bonds, and alkyne, yne, triple bonds. So this ends by what? ene. ene, that means double bond, and the double bond has a hybridization of sp2. Which of the following properties belongs to diamond? Belongs to diamond. Conduct electricity and heat? No, it conducts heat but not electricity. Does not conduct heat but conduct electricity is not. Does not conduct heat and electricity? No, it conducts heat. A conductor of heat but does not conduct electricity. D is the correct answer. Thank you for the attention, guys. That's the end of the first section.